So right now we're in the bottom room of the LIDAR building, and this is where it all begins. This is the laser and the optics. So what we have here is a large box which contains all of the optics that create the laser light that we use for LIDAR. We can actually open it up and have a look. Maybe we'll take a shot of that later on. So inside here we have the rod in which the laser light is generated, and that operates being charged up by a flash, what's called a flash lamp. And so we have this lamp which flashes energy into this this crystal, and all of that energy builds up in the crystal, and then eventually it gets emitted as laser light. And then there's a couple of mirrors here. The laser light bounces in between, and that builds up, and eventually builds up to a point where we think it's strong enough, and we use an optics called a Q switch, and that releases all the laser light in a pulse, a very strong, intense pulse, which goes in actually does a U-turn around here and goes through two amplifiers, where it picks up more energy, and what comes out of here is actually invisible laser light, and that gets amplified, and then it goes through this crystal here called a second harmonic generator, and that actually doubles the frequency of the laser light, which basically means it converts it from infrared to green. And that's the characteristic green that you see coming out the top of the LIDAR in all the photos, and we'll all see in winter later on. Oh hi, I didn't see you there. We have so obviously you may have noticed that the laser is actually like horizontal on the table, and that's a bit of a problem considering that we want to shoot into the sky. So we have the light comes out here, and a 45-degree mirror reflects it straight up here through the ceiling of this room, with a little bit of light actually passing through that mirror, so it's not 100% reflective. And here we have a photo detector which basically just tells us the power of the laser and whether it's running well. We've actually got that information all going, along with other things, going back up to the control room up here, and that tells us whether the laser power has gone down to a level which is sort of unacceptable for its operation, and we can come down and do various things to fix that up. We also have a pager so we can walk around and get information about little things like that might be going wrong in the system as it's running. So that's good to enable us to leave the building from time to time and get out while we're running it for hours. You know, these just come up, don't they? What we have here is the optical setup for processing the received light from the LIDAR, which comes through a telescope up the top there, and gets channeled through an optical fibre into the top of this fairly complex looking array of optics and electronics. The purpose of this is to filter out a lot of the background light that we get from the sun, because that can really interfere with our signals. And so we have these two what are called etalons, which are essentially optical filters that are very tightly controlled to be a specific length apart, such that they allow through the same kind of light that comes out of the laser. Now that light, if we didn't have these in place, would be heavily drowned out by a lot of the background light from the sun. So all of the electronics around here are for controlling the temperature in there, controlling the distance between the plates, and that has to be controlled to like about the order of a millionth of a millimetre in order to make sure that we're getting the right kind of light through for processing the data. And if you move even a tiny little bit away from that operating condition that we're trying to set up with these filters, then you won't be able to get the data that we're looking for. So there's it's a lot that goes into it actually.
So we can now put the parallelism and stuff back in.
Okay.
Which I can do.
And that goes in a hook there, doesn't it?
Right, George, I think I've got it.
You got it?
You see that? This is just to cut out some of the light.
Yeah, right.
I've seen them, yeah, I've seen them. Friends of mine work on the Devil program.
It's been there for 14 years now.
Going to go down to history. We look like a lame duck.
I was disappointed with all your marks.
Serious business going on here, mate. This is how you pour a beer.
Pull it out, but if you like that, you can't shut him back in, right?
Anyone else up here short of liquid?
Supporting science in Antarctica. Cheers.